Hello everyone, welcome back to channel. My name is Mayank Gupta and today's question is set matrix zeros. LeetCode 73. So this question is very simple and is asked in a lot of FAANG interviews. Now what the question says, we are given a matrix. So this is an M cross N matrix, and what we have to do is we have to identify all the positions with 0 and mark their rows and columns as zeros. So I hope you understand the question. We are given a matrix. We have to identify all the zeros in it. Suppose this is a 0 and mark all the complete that row and that complete column as 0. Now when we try to do this, we held up with the problem. So suppose for an example we had this as 0, already this has 0, but now if we do an in place check, so let's go in the page and let's see. So the cascading trap that we are talking about, it's actually like if we had this as 0 and we marked all of its row as 0 and then all of its column, we will never be able to identify what was the actual value. And if this was a 0, how, whether we should mark this zeros or not, this column. So that is what problem that we are trying about. If we modify in place immediately, the new zeros act like original zeros. The whole board gets wiped out. So we don't have to do that. So how can we do it? So the first approach is we can make a direct clone of it. So how will it work? It's very simple. We have this input matrix and we have this clone matrix. Now how can we do that? We identify all the zeros over here, and in the cloned matrix we mark all the values 0. So over here in the input we are generating, like we are getting the matrix positions and the rows and columns that we have to mark zeros, and in the clone one, that is our output matrix that we are preparing. But the complexity for this is O of M cross N of time as well as space M cross N, because we are creating a completely different matrix that is getting outputted. Now the problem is the space complexity. We don't want this complete matrix to be a separate thing. Now how can we optimize this approach? Now one thing that we need to think about is what are we outputting? Our output is actually the same matrix, but we need to keep track of rows and columns. This is what we need to keep track of, whether this row is 0 or not, whether this column is 0 or not. So what we can do, we can create a completely different array, okay, and for keeping the track of columns as well as for keeping the track of rows, and for each of them we can identify whether, okay, we got 0 over here, then it should be marked as 1. It should be marked as 1, and wherever we see 1 over here, we are gonna mark that row. If we see 1 over here, we're gonna mark complete column as 0. If we're gonna see 1 over here, we're gonna mark complete column as 0. And same for the row. If we're gonna see this as 1, we're gonna mark complete row as 0. So this approach is a better one than the brute force approach that we just saw. Over here the space complexity has got reduced to O M plus N, because we are not creating a completely different matrix but just two, the one array of M size and one array of N size. So this has got reduced, but the most asked interview question is actually to do it in place, to do it without space complexity. Now how can we do that? Over here we have to do it in O1 of memory. What can you think about this? So over here if you see, the actual problem is that we are just creating columns and rows array. Now can we actually in place this over here in the first row and the first column? Do you get my point? So just the array that we were maintaining over here, we're going to maintain in the first row and first column. Now suppose for an example, here we found out 0. Now if we found out 0, we're gonna mark this as 1, we're gonna mark this as 1, or suppose minus 1. We're not gonna get confused in this 1 and zeros, so we mark this minus 1. Now if we saw -1, if then we are going to end the last, we are going to traverse this rows and columns, and wherever we see -1, we are going to mark the complete row and the complete column as 0. So now the problem is, this is the overlapping index. Now if we go behind, I just remove this. So if we see the columns and the rows that we are seeing over here, this one is getting overlapped. Now if this is marked 0, how are we gonna see that this is for this complete row or this complete column? Oh shit, now this is a problem. Then how can we do so? It's very simple. We can create a new variable. So how will I solve it is, I'll just create a variable 0 col. Okay, and consider this for row. Now the column would be over here. This will be the array for column and this will be the array for rows, and the 0 column will be actually identified from this. Simple, right? So because we are creating only one variable, it's one extra variable is O1 complexity only. Now this is how we do it. I hope you have understood the problem. Now how can we actually leverage it? So first we need to find out the core that we are gonna loop over here. For all the values that we have, we are gonna mark the inside matrix as zeros, but not touch the outer arrays. Why do we have to do that? Because we are doing in place, we have to touch them in last, because if we have -1 anywhere, we can lose that. We don't have to, we have to keep track of that -1. That's why we are touching it last, and at the end we are marking all zeros. Now the same thing, handle the border at last. Now the in place approach is actually OM cross N, and time complexity because we are looping it once, but the space complexity is O of 1, which is great and superbly asked in interviews, and once you tell that, you are definitely getting hired. That's done, that marks done. Now we are going to jump into the LeetCode solution. I want you to, if you have understood it properly, I want you to actually try it on your own, and if you're gonna do it, if you actually make it right, it's super. You have done it. Thank you.